Hi grade 10s, welcome to today's session of Learn Extra. My name is Hayley and I'm going to be taking you through the session about graphs. We're going to be dealing with more graphs, and when you think we've done enough, we'll probably just do just a little bit more. Let's see what our key focus is. First of all, we're going to look at the different types of graphs. Now what's important about this session is that every part of Maths Lit and every part of your syllabus can come down to graphs. So it is really important that you keep revising graphs. You can't just do it once in like a little part of the section and forget about it, because it can come up in so many different questions. We can be doing a percentage question where it can be graphs. We can be dealing with data handling and statistics where we've got graphs. So it really is important that you keep coming back to this and refresh graphs. So let's look at the different types of graphs. We're going to be dealing with line graphs, bar graphs, histograms, and pie charts. Most importantly, we're going to be looking at drawing graphs, and finally, we're going to be looking at interpreting graphs. So before I move on from this slide, let's just briefly discuss what each one of these graphs is. So I'm going to find some space here, and I'm going to look at first the line graph. Well, what does the line graph entail? First of all, in Maths Lit, we normally deal with positive values. Remember we discussed at the beginning of the year where our numbers come from, and we had very few negatives. We had negative values, I think, in temperature, and we had negative values in maybe money. But most of the time we're dealing with positive. So we're going to be dealing with our x-axis and our y-axis just being positive. And this is where we're going to draw our graph. Okay, so let's not draw a circle. Right, so if I look at my graph, and you don't need to label them x's and y's, but just for today's session, we're just going to discuss what they are as the two variables. So, okay, but I know you've seen this before, so I'm going to deal with the x's and y's. A line graph is just that, it is a line. It tells us information, and it is continuous information. So I have a line graph where we join up points. I can have a line graph going positive. I can have a line graph, let's get another color. I can have a line graph that has negative. I can have more than one line graph on a graph, on a set of axes. And all of these, we're going to learn how to draw them and interpret them. So let's take it one step at a time. Right, the next graph, before I carry on, another graph, which is also we call a line graph, but you might see a line graph that actually, it doesn't look like an H, let's try that again. A line graph where you actually have a dotted line. So a line that kind of looks like that. And you do get a graph that is a broken line graph where it is not continuous data. So for example, if I was looking at the cost per person of going in a bus, okay, the less people in the bus, the more it's going to cost. The more people, the less it's going to cost. So we're dealing with more and less. But I cannot have 1.5 people. I can only have one person or two people. I cannot do a reading in between. And that's important to note. Continuous data where your lines connect. So if I have, let's find more space, continuous data, I can read a value in between. Okay. So say between 1 and 2. But if it is a broken line graph, I cannot read a number. There is either 1 or 2. It does not make sense to have 1.5. So that's the difference between the two. Okay, we'll come back to those later. Let's move on to the next graph. The next graph we've got is a bar graph. All right, so let's change our color, and we've got a bar graph. Again, in our positive axes, most important thing about the bar graph is that you can see through the columns. Imagine you're sitting behind bars like in a prison cell. You can see through, and that's what's important to note. So we always start with a space, and then we will have our first bar, and then our second bar, and we can carry on with as many bars as we need. So there is space in between. Where we compare this, let's just label that, that's a bar graph. Compare that to a histogram. So let's do a histogram in orange, where we have our lines. Now we don't have a space in between. Our columns connect to each other. This is called a histogram. They look similar, except for the spaces, they look similar. So why would I use a bar graph and not a histogram, or a histogram and not a bar graph? So what is important to note, on a bar graph, they are not continuous. And in a histogram, we have continuous information. What do I mean? Continuous information means that it follows on. So there is a particular order and way things are done. So for example, if I go from 0 to 100 and 100 to 200, 200 to 300, they follow on. I can't decide, well, okay, I'm going to put 300 first. Well, a good example of that, say, is months of the year. They are continuous. We go January into February into March. I can't decide all of a sudden, well, I happen to like June. June's a nice month, so I'm going to have June first and then go January, February. That's not how it works. It is continuous. Whereas if I've got non-continuous data, I've got separate variables. I've got separate categories, and I can put them in any order. So if I'm looking at hair color and I can go black and brown and blonde, well, I can decide, well, no, I've got brown color hair, so I'm going to put my brown first. I'm more important. I can go brown, then blonde, then black. So always ask yourself, whenever you're doing one of these graphs, can I choose the order of the categories? If your answer is no, you need to be drawing a histogram. If your answer is yes, then you can be drawing a bar graph. Okay, so that's a good little hint there. And finally, our final graph, let's just go back and check. Our final graph was our pie chart. So a little bit more space. Our pie chart, remember, is parts of a whole. So our whole is the pie, and our parts in between are how we split up the pie into parts. Each one of these in your pie chart represent a percentage of the whole, a percentage of the whole circle, and that the way we calculate them is we have to work out the number of degrees. So what we know about a pie chart is that 100% is also equal to 360 degrees. And when we do one later, I'll show you how to do all the calculations. Now, I know when I'm teaching, I don't actually ask my kids to actually draw a pie chart, because I just assume that they don't have protractors with them. But that's not to say that your teachers won't. I have a feeling that in our final matric paper they won't actually ask us to draw, but they can ask us to interpret. Don't take what I said as face value. It's just something, a feeling that I have. Right. Let's move on, or let's first check we need drawing and interpreting. Right, let's move on to our next slide. Most important part about drawing graphs and interpreting graphs is, well, okay, let's do drawing graphs first. What are the key elements that we need to discuss? First of all, every graph needs to have a title or a heading. Now, your title and your heading is really, really important. I need to be able to look at it. Somebody else needs to be able to look at it. Your examiner needs to be able to look at it and say, I know what it is. Because why? Because you've given us a heading. So, and it's important that you give us a heading that is meaningful. So I want to add to this, I want a meaningful heading. Meaningful. I do not want to know that it's a line graph. I can see it's a line graph, but what is it a line graph of? So in your title of your graph, I want you to discuss both variables. What are we looking at? We might be looking at the number of people in a taxi. We might be looking at the cost per pen. So I want you to talk about both, and you need to include both variables in your heading. So be very specific, exactly what the graph is about. Then the next thing that's important is we need to have a title on our axes. So if I draw a quick axis, what do I mean? I told you earlier that this was X and this was Y, but that's not important. So in actual fact, let's delete those. What I need to know is you're going to have a heading here, and I need to know a title. What is this title? And I want you again to be specific and to include the units. So if I'm, for example, looking at cost, and I want to know that it is in Rand. And here I might be looking at, I don't know, months of the year. Even if you've got January, February, March, I want you to tell me that it's months of the year. So don't assume that I know anything, and don't forget your units. So we need very accurate account of your axes. We need to select a scale. Now our scale needs to be selected very carefully. So when we select a scale, we normally start at 0 on both axes. And we need to go up to what is our highest. So we're going to look at our values. You look at your lowest, which is very often 0, and you're going to look at your highest. And then you're going to take your graph and you're going to say, well, okay, if I've split this, say, into 4 values, let's just assume I had 4 blocks, I'm going to take my highest and I'm going to divide it equally into those 4 blocks. You might need to round up, and you probably will need to round up, and I'll show you an example of this when we do a question. But it's very important that you have the correct scale. What's really, really crucial is that each block must represent the same number of values, same number of the variable. So what I mean is that I cannot go, well, 5, so the first block represents 5, and go to the next one and say, well, that's 15, because then the next block represents 10. I cannot do that. So that is, in fact, wrong. What I need, if I'm going up in 5, then I must go 5, 10, 15, and 20. So 15 would be there, and 20. So it's important to go and check your scale out and then divide it equally. And each block must represent the same number of units. Finally, we need to, of course, plot our graph accurately. So each value, I'm going to draw this again. So each point on my graph, each point has an address. This point over here represents, let's find a straight line, see if we can do this with a straight line. That point represents a value on the y-axis and a value on the x-axis. So it's important to note that your point here has a specific address, and that's where you need to be very accurate. Now, one hint for you, when they give you a graph to draw, they're probably going to ask you to calculate certain values, and then, but they've given you a table with some values already given. Always use the values that have been given to you to draw the graph, rather than the ones that you have calculated yourself. It always just gives you a little bit more of a hint, and then when you do your calculation, you come back and check if it fits on the graph, especially if we're dealing with straight line graphs. So that's something probably will come up later in the session, and I hope that you understand what I mean. Use what's been given to you first. Okay, let's move on to the next slide. When we interpret graphs, another important skill. Whenever you get a graph in a question and you need to interpret it, always look at the graph first and make sure you understand the graph. What are they trying to tell you? And then it'll be easier for you to answer the questions. So the first thing is, what are we going to do? Well, we're going to look at the title, because my title or heading is going to give me that information that I wanted you to give me just now when we were drawing graphs. It's going to tell you what the graph is about. It's going to tell you the variables in the graph. And it's going to give you a clue as to what you're going to be looking at. So really your title is very important. Then go and read the title and units on the axes, because then you know what each variable is, because there'll be 2 variables, 1 on each axis. So by reading the title and reading the units, you will know exactly what the graph is talking about and what the graph is representing. And then finally, you need to make sure you can read off information from a graph. And the only way to really do this is with practice. So what I suggest you do, go get your newspaper. Take out the newspaper, open it up. Go get the Business Times, it's got really nice graphs in it. Go open up the Business Times, take out those graphs and see if you can interpret what the graph actually represents. Read the heading, read the scales, read the axes and see if you can understand the graph. Go find there's plenty of graphs all around you. Newspaper's one example. Have a look in some of your other textbooks. You might find graphs. Have a look in your Math Lit textbooks. You're going to find graphs. Have a look on the internet. There are plenty of graphs on the internet and see if you can interpret what the graph is telling you. Because remember guys, a graph is like a picture. It tells us a picture says 1,000 words. I think a graph says more. So that's what you need to do, and it's really just practice that's going to actually make it better. Now I think before we go on to our actual line graph and drawing some graph, I think it might be time to take a little bit of a break. So go get something to drink, but hurry back because we're going to carry on with the show in a moment. Welcome back, grade 10s. I hope that I've given you a lot to think about, but now let us do a little bit of practice and let us look at each graph and an example of each. So let's start off with our line graph. So we know the theory. Well, if we look in this line graph, what are we doing? We're interpreting. So the first thing we're going to do when we've got our line graph, a little bit more space, is I'm going to read the title. This is a graph showing the distance and time that Tumi walked on Saturday. So what am I looking at? Remember I told you that your title needs to have both variables. Well, where are my variables here? I'm looking at the distance and I'm looking at time. So I'm going to just delete those yellow lines. So those are my two variables, and I know that we're looking at Tumi and a walk on Saturday. So let's now go to each of our axes. So I'm going to I'm looking for distance and I'm looking for time. Those are the ones that I'm going to be looking for. First of all, on this axis, my y-axis, I've got the distance. It tells me distance and it tells me that it is in kilometers. And it's really important to note. So she's walking somewhere between 0 and 20 kilometers on this Saturday. About 20 kilometers more than I would walk on a Saturday. But having said that, right, let's carry on. What's our other one we're looking for? Time. Well, there you go. Our time is on this axis and this is in hours. So she's starting off at 8 o'clock in the morning and she's walking until past 11. Let us quickly look at the scale because I just want to show you again what I mean by even increments. So we have got quite a few blocks. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 10 blocks, but we needed to go to 20. So what did we do? We took our 20 and divided by 10, and we ended up with each block representing 2 units. I didn't have to label all of them. I labeled 0, 4, 8, 12, 16, and 20. But each 2 blocks represents 4 units. I don't have jumping from 4 to 20. I don't have a jump from 0 to 20. I have even increments. And the same thing with the time. I'm going up and I'm kind of doing 4 blocks is 1 hour. Okay, 1, 2, 3. No, I don't think I've got 4 blocks in 1 hour. Yes, 4 blocks is 1 hour. And the next 4 blocks and there's my next hour. And another 4 blocks and there's my hour. So it is important that we have the same increments. Okay, let's see what our graph says. Well, first of all, from our graph we can see a number of things. We can see that she started walking at 8 o'clock. How do we know she started walking at 8? Because at 8 o'clock she had done 0 kilometers. So at 8 she had traveled no distance. So it's important to note she started at 8. So we can actually say that she started her walk at 8 o'clock. Right. After 1 hour, we can read how far she'd gone. Let's get this out. Right, we'll do it with that. At 9 o'clock, how far had she traveled? So we're going to read from our 9 o'clock, we're going to read up to the graph and then across from the graph to the other axes. And we're going to see that after an hour, she had traveled 4 kilometers. So in her first hour, so we've got our first hour, she traveled 4 kilometers. Now you can see that this graph is a straight line and it is a constant line. We don't have any movement up or down. And what does that mean? It appears that she is walking at a constant rate. I'm going to come back to that rate in a second. Let's just check out our theory. In our second hour, let's look at our second hour. We go from 10 o'clock up to our graph and across from our graph, and we see that she got to 8. So our second hour, she got to 8 kilometers. And what does that show us? Well, if we take the one and minus the other, we can see that, get more space. In the first hour, she traveled 4 kilometers. And in the second hour, we're going to take 8 minus 4, she traveled 4 kilometers. So she is traveling at a constant rate. And remember that the speed, that's what I mean by rate, your speed is equal to the number of kilometers divided by your time, or should I say distance? Let's rather say distance divided by time. And she's traveling at 4 kilometers in 1 hour. So she's traveling at a constant speed of 4 kilometers per hour. It's a constant speed, and that is why we've got a straight line just going up. We can do other things from this graph. Well, we can say, well, how long will it take her to travel a certain distance? So let's look at that. If I say, well, how long will it take her to travel 10 kilometers? So I'm going to find 10 on my graph. Now remember, there were even increments. So 10 is between 8 and 12. I'm going to draw a line to the graph. And then I'm going to draw a line down from the graph. And then I get to read this value over here. And that value over there, well, it's between 10 and 11. Therefore, it must be 10:30. So let's just add that calculation. So it took her 10 kilometers. She did in 10. By 10:30, she had traveled 10 kilometers. How long did it take her to get to 10 kilometers? Well, when did she start the race? So we're going to have to minus our original. She started the race at 8, so it took her 2.5 hours to walk 10 kilometers. And our final question we can ask about this graph is, how far did she actually walk? So, well, she definitely carried on past 11. So, how many kilometers did she walk? So let's get a line. Right. And our final distance, draw a line across. She walked, now this is in between the lines, so we got 12, 14, 15 kilometers in total. And how long did that take her? Well, we draw a line down, and I think I better start that line again. We draw a line down from there to the end, and we can see that was 11. We've got till 11:45. Okay, because our 11 was there. No, let's undo that. We've got 11 there, and there's 11:30. Remember, we were dealing with 4 blocks per hour, so every block must represent 15 minutes. So she finished walking at 11:45, and she had done 15 kilometers. So just from looking at this graph, there were a lot of things that we could interpret. But I tell you what, this was an easy one because this was a straight line. Let's go and see what the next one is. The next one, we've got a graph showing the distance and time. Same thing, distance and time. But now we've got Mpho, and she also walked on a Saturday. Okay, so again, my heading, my title tells me a lot of information. My axes, I'm going to guess, are probably the same. We've got the same distance in kilometers, again going up to 20, and we've got our same time. But this graph does not look at all like the graph I just showed you. Whereas the other graph was just a straight line, this one has lots of different gradients. Okay, we're going at lots of different rates. So let's quickly discuss some of those. So let's look at our graph. Let's find some place here. Right, did she start at the same time? What time did she start? So we're going to go, well, she started at 8 o'clock. So they started walking at the same time. I wonder if she ended. Let's see where she ended. Right, what time did she finish her walk? Well, we're going to have to take our line and get time from the end down. She finished at 11:30. Remember, there was 11. Let's go back to a pen. We had 11 there, and 2 blocks represented 15 minutes each, so she finished at 11:30. So she finished a little bit before. Okay, so what happened to her walk? Did she walk the same distance? Let's check that out. So we're going to draw from our end point to there. She did not. She actually only walked 14 kilometers. Okay, so her total, let's write that in somewhere, her total, she walked 14 kilometers. Again, probably 14 kilometers more than I can do. And let's look at our different times. So we're going to look at every hour, and let's try and get a rate that she walked per hour so we can see the difference. Right, in our first hour, we're going to read up from our first point, 9 o'clock, to the graph, and across from the graph was 4 kilometers, same rate. So in our first hour, so we're going to put our first hour, we went 4 kilometers, and that was in 1 hour. Okay, our second, right, 10 o'clock, where's our 10? 10 o'clock was actually there. Right, at 10 o'clock, that's after 4, we're going to draw a graph up to our graph and across, and we're going to see that she's done kind of a little bit more than 9. So let's get our lines out. And why do I say a little bit more than 9? I'm going to go there. So second hour, we went, so that's hour, and we're going to work out how much she did in that hour. So in 1 hour, I'm going to give you that answer. Why did I say a little bit more than 9? Right, if I've got 8, that's 10. 9 would be in the middle of that block, and it's a little bit more than 9. So that's why I said a little bit more. So I'm going to go to say 9.5 kilometers. Now remember, guys, there is a little bit of leeway when it comes to graphing. We do give you a little bit of kind of choice between one or the other. If it's specifically on a line, then it's either right or wrong. But if you tell me this is 9.5, or you tell me that it's 9.25, or maybe 9.6, I'm going to give you the benefit, and I'm going to give you the marks. It cannot be 10, and it definitely cannot be 9, but it needs to be somewhere between 9 and 10, and I would give you the benefit. And I'm sure your teachers would too. So how many kilometers did she go at this, in this hour? Let's get a different color pen. In this hour, we had, well, we've got 9.5 minus 4, so she went 5.5 kilometers in the second hour. And then in our third hour, well, she hardly moved at all. I want to discuss this point here where she's actually just stationary, I think. So at this point, from just after 10, from 10:15, let's get a line. From this point here, which I say is 10:15, to this point here, 2:11, what actually happens? She stays stationary. Her number of kilometers does not move at all. So in that 45-minute break, in that 45-minute period, should I say, she did not walk. So she took a break. So this orange line here actually represents a break. And how do we see that? We see that as a straight line because kilometers did not change. The time carried on moving. The time just carried on going, but the number of kilometers that she walked did not change. So in actual fact, in her third hour, in her third hour, she took a very big break. Third hour, and we're going to work out 1 hour here. What do we end up with? We end up with 10 kilometers. So she actually only moved half a kilometer, or 500 meters in that time. And the rest of the time she was sitting and just resting. And then in our last hour we can work out how she went, and I think now she went quite fast, because she went from 10 to, well, in actual fact from 10 to 14 she went back to the same rate she had at the beginning. So can you see how much information we can get out of a graph? And if we had to answer questions now, well, we could answer any question that they gave us. So that is what you need to do when you see a graph. Okay, let's move on to the next graph. Well, in this case I have a bar graph. So my bar graph showing colors of cars. So what is my heading telling me? My heading telling me, what am I looking at? Showing the colors of cars. We're looking at the number of cars on our one axis, and we're looking at the color of cars on the other. Now this is an important fact. Can we put these into any order? We can. So whoever drew the graph said, well, white, then black, then red, and then blue. But you know what? We could change that totally around. We could say red first, white, then black. But you know what? That's how we know it should be a bar graph. What is important to note about a bar graph, whenever you draw one on your own, you have to have a space first. So we start off with a space, then we have our first column, and then we have a space, second column, space. Now there's a couple of key characteristics. Our columns or our bars need to all be the same width. You cannot compare bars if you've got one very wide column and a narrow one. It doesn't look right. It needs to be the same. So if ever you're drawing your own bar graph, use a ruler, guys, and make sure that you draw your axes, a space, then your first column, and if your first column is 2 centimeters or 2 blocks or whatever it is that you're using, then you need a space, and you need the next one to be exactly the same. Your spaces in between don't have to be the same. Well, the spaces in between should be the same if they look the same, but they don't have to be the same width as the column. That's what I mean. In this particular case, we do have the same width. We've got 2 blocks per column and 2 blocks per space, but I could have moved the columns up. It's also nice to spread out your work and make it as big as possible. So with my number of cars that I'm looking at, a total of 500. From this graph, what can I see? Well, I can see my most popular car color is the one that is the highest. So that is the most popular, the first one. Which is the least popular? Well, I'm going to look for the one that is the lowest. So that is my least popular. I can look at reading the values of each one of these. So let's see, how many white cars were there? Let's take a line. We're going to look at our total of the white cars, draw a line to the axes, and then draw this value here. And I can see that there were 450 white cars. So let's write that in here. We had 450. How many blue cars did we have? Again, let's take a line. And remember, guys, do this with your rulers. You have to have a ruler. It's really important that you're accurate. We're drawing a line from there to our axes, and we're going to do this reading here. And what have we got? Well, it's between 100 and 200, right in the middle. So it is 150. I've got 150 blue cars. From this, I could say, well, how many more white cars have I got than blue cars? And then I could take the one and minus the other. And just the simple maths that'll come out of this is stuff that you can access. But you need to be able to interpret the graph. And you need to be able to draw this kind of graph. Right, let's move on to our next graph, because I think we've done that. Our next one is a histogram. And our histogram is showing marks for a particular grade. So now we're looking at the number of learners, and our maximum learners, there were a total of 50. That was the maximum in that particular group. And we're looking at marks as a percentage. Now, can you see that this is continuous? I can't decide, well, okay, I would like to start with the distinctions and go from 80 to 100, and then we can do the ones that got between 0 and 19. No, I need to go in a specific order. So I've got from 0 to 19, 20 to 39, 40 to 59, 60 to 79, and finally 80 to 100. In each one of these, I can read off the graph how many were in a particular category. So let's look at our highest category. How many were in our final category? Well, we read off the graph, draw a line from there, so we can see that there are 40 here. I need a pen for that. Right, so there are 40 learners that got between 40 and 59. What we can see from this is how many learners were there in total. So let's quickly do that calculation. So I'm going to read this one. Well, that's easy to read off because we've got 5 there between 0 and 10. Then I'm going to use my graph to read off the second one. Now, again, not exactly on the line, and we can probably have quite a bit of leeway. We want to read this value here. We can see that it's definitely more than 15, and it's very close to 20. So I'm going to go with it's probably 19. So and this is where my kids laugh at me. I say to them, we'll have a guesstimate, but it's an educated guess. So I know where 15 is. I know that halfway between 15 and 20 would be 17 and a half, and this is still higher than that. So I would have gone with 18 or 19. So let's go with 19. Then I've already calculated that as 40. Let's do the next one. We need a line for that. Okay. From there, again, we're going up. So we've got 25, and I'd say that's about 27. And again, this is something that you need to practice. And our last one, we draw the graph line across, a straight line, and it's just above our 7, and I'd say that's 8. So now I can actually tell you how many kids wrote this exam. So I can get a calculator out and I can add these all up. Let's do that quickly. Get a calculator out, and I've got 5 plus 19 plus 40 plus, I need the numbers again, 27 and 8, 27 plus 8, and I get a total of 99. I've got 99 learners that wrote this exam. Now remember that I've said 99 in total. Remember I've said 99. You might get an answer of 100 because you might have made this 18, maybe made this 9, maybe made this 27. There could be a little bit of leeway. So I would imagine that anywhere kind of between 98 and maybe 100 to 101 would probably be a fair answer. Where I would not give you any leeway is on the 40 and on the 5. There would be no leeway. That would have to be 40 and have to be 5. And in actual fact, if I was marking this type of question, that's probably where I would give you a mark allocated for actually reading that accurately. With the others, I would give you a little bit more leeway. And remember, if it comes up, you need to show all your workings, so you would need to show that you needed to add all those up. Okay, that's just one question related to this particular graph. So, should we move on to our next graph? Our next graph is a pie chart. And in this pie chart, we're looking at, let's move it up a little bit. Our heading is the 2011 budget. Hey, this came out, a budget speech. We are now looking at a pie chart. And this particular pie chart, they've actually split the pies up. They've kind of like moved them a little bit apart just to separate them. But we could bring it back together into our normal pie that we expect with sectors. We got how much is going to be spent is our title, another title to this graph, and we can see that each one of these charts, each one of these pies represents an amount of money, because we're dealing with how much is being spent in money. So each one represents an amount of money, and it tells you where that money is going. So for example, this big pie here that I've got here, this piece here, is represented 189.5 billion rand, and that goes towards education. And each one of our pies goes in order of how much is being spent and where it is being spent. So you can see, for example, if we compare education with defense, our defense was 38.4 billion, still a huge amount of money that is going to defense, but as part of our whole, as part of our entire budget of where the money is going, it's a very small fraction. So it represents a small piece of the pie. So even sometimes we're dealing with huge amounts of money and huge values, but it's a small piece. Each one of these is part of a pie. So when we're doing our calculations, we would look at our fraction. So let's just work out how we would work out our calculations. So we would basically look at our fraction of the money. So how we're looking at, look at the defense, we would look at the amount of money spent by the defense, our 38.4 billion. And we can leave our billion. I know there's lots and lots of zeros. We can leave it as billion because we're dealing with billions in total. And we're going to divide that by our total that is being spent. If I knew the entire total, I'm not going to sit and add it up now. And we're going to get our fraction. We're going to get it as a percentage. So times by 100 will give me a percentage. And I'll see that that percentage out of 100 is actually quite small. And the next thing we need to do to actually work it out, as to draw it, to work out how big our portion is we take our same fraction. So I'm going to put the same fraction divided by the total amount that we've spent, and we're going to times it by 360 to get our number of degrees. I think it might be time to take a little bit of a break. So go get something to drink, but hurry back because we're going to carry on with the show in a moment. Welcome back, grade 10s. I hope you enjoyed your break and you got a little bit of a stretch going on there, but I hope that you're back and focused now because now we're going to do some questions. So let's see what our first question is. Right. A game warden does regular counts of animals at the waterhole in his game reserve. The table below shows a sample of his data collected from 3 o'clock until 6 on one day. So at his game, we've got impala, he counted 240, zebra 150, giraffe 35, and elephants 25. I think I would have loved to be sitting at that watering hole at those particular hours. It would be nice to see. Anyway, let's see what the question says. What type of graph would you suggest the warden draws to show this information? Now, this is important. What have we got here? We've got 4 different types of animals. I can put these animals into any particular order. They do not follow each other. So my guess is we're going to be drawing a bar graph. So we're going to be drawing a bar graph. Now, are there any other graphs that would work? A line graph? Well, they're not connected, so we can't draw a line graph. Histogram, we know that there's definitely a particular order. I suppose if we really had to push it, we could draw a pie chart showing the total number and the percentage of each one. But I think what the warden really wants to see is the number of each animal. So because he's looking specifically at the number of animals, it's more important that we draw a bar graph. Now it says draw the graph that you have suggested above. So first thing we need to draw when we do a graph is we need to do a heading. Now heading is the number of animals at a watering hole in a particular time. So remember, I want you to have both axes. So we're going to be looking at the number of animals. There's my one. The number of animals is my other during a certain time, during a time. Right. Our next important thing is to look at our scale. So remember I said to you, whenever we're doing our scale, we need to look at our lowest value and our highest value. So our lowest value is 25, but I'm going to start at 0. Our highest value is 240. So we need to make sure we get up to 240. So let's go to our graph and see how many of these blocks we have. Well, I have 10 blocks. If you count them, I've got 10 blocks. I'm going to start at 0, and I need to go up to 240. But 10 blocks, it's going to be easier for me to round up and to go up to 250. So I'm going to make the top one 250. And if I've got 10 blocks, then what does each block represent? Each block represents 25 animals. So I'm not going to label each one, it's really not that important. I'm going to label every second one, and I'm going to say that's 50, 100, 150, and 200. So can you see the way I did this? I started at the top and the bottom, and then kind of filled in all the values in between. And remember, we need a heading. So what is this? This is the number of animals. So don't forget your titles. Right, on my y-axis, what am I looking at? Well, I've got 4 different types of animals. So I'm actually going to put my animals in here. Remember, I need a space first, so I'm going to put my first animal between there. And what was our first animal? We needed impala, so I'm going to put impala. I'm actually just going to use the letter I, but you would probably write it as impala. Then I'm going to leave a space, and I'm going to do the same width, and I'm going to do the next one, which is zebra, and I'm going to leave the same space. The next one is giraffe, and a space, and our final one is elephant. Now, if you're going to use keys like I just have, please on the side make sure that you say that I is impala and etc., etc. So for the purpose of today, I'm not going to write it all out. Right, now what's important is to get this reading. So our first is impala, and we need 240. So what we need to do is we need to find out, we're going to use our straight line. Right, we're going to start by finding 240. So if that's 200 and that's 250, 240 is about there. And then I'm going to draw the lines going down. And finally, you can color it in, make it look pretty. The next we're looking for zebra. Zebra is 150. So again, I'm going to find the 150. So my zebra is 150 and mark down. It probably will be easier for you when you're doing this on your own is to actually start by drawing the line going up. I'm just finding it easier to, with the board, to actually fill in the line on top. But giraffe, we needed 35. So now giraffe, 35, 25. I need a little bit more than 25. So there's my giraffe. That's not straight. Let's just redo that one. And finally, my elephant with 25. So my elephant are on the line and 25 going down. Not exactly straight. Let's try straighten those. Right, so that's my elephant. And then I could color this in and make it look pretty, but I have drawn the graph exactly the way they want. I've got a heading, I've got a label on both my axes, and I've got the graph drawn accurately. So let's see what the next question is. Next question says, a food technologist analyzes the percentage. Now, what's important about this is that we're dealing with percentage of nutrients in a sample of bread. She records these in a table below. So we're looking at, in our bread, we've got a table of our nutrients and the percentage in each. So carbohydrates, we've got 60%, fat 20%, fiber 15%, and protein 5%. Now, if I add these all up, they should add up to 100%, which in actual fact they do, because that's my whole loaf of bread, my whole slice of bread, what was she looking at, sample of bread. So what type of graph would you suggest she draws to show this information? We're looking at parts of a whole. We're looking at how much of each nutrient is in the bread. Parts of a whole would basically be a pie chart. A bar graph would work, but it would not show me parts of the whole. So can you see both of these questions, we were able to kind of intermingle the two, but I think make sure you understand when they're asking you for parts of a whole, then it needs to be a pie chart. So in this case, a bar chart would not work, a bar graph would not work as well. And now they want us to draw the graph that you have suggested above. So before we draw the graph, what we need to do is we need to do some calculation. So I'm going to, first of all, start with each one of my things. I've got my carbohydrates, which was 60%. I'm going to write that as a fraction, which is 60 out of 100, and I'm going to times it by how many degrees are in a circle. Or I could have actually just done 360 times 60%. So either way it would work. So let's try that. 360 times by 60%, and I get an answer of 216. So we need 216 degrees. And I'm going to do that for each one of them. So fat was 20, and again I say 360, let's do it this way now, times by 20%, and I will see that fat needs to be, I need a calculator, 360 times 20%, and I get 72 degrees. Our next was fiber, was 15%. Again, let's just do the calculation. I don't think I need to write it again. 360 times by 15%, get 54 degrees. And finally, our last nutrient was protein, which was only 5%. And we can do that calculation, 360 times 5%, and we get 18 degrees. Now that I've got all these degrees calculated, I can actually use them to draw my pie chart. So let's try this on some space here, and I need a circle. Let's start with a circle, and let's maybe we move that circle to here. Right, start with a circle, and I'm going to always start from the center. Now this is going to be a bit of a guesstimate. Let's use a line, start from the center and draw a line up to 12 o'clock. And that's how I always start my pie chart. Now I need to measure my first chart. So my first one was 216 degrees. So I'm going to try and get myself a protractor and see if this is going to work. So now the protractor, just need to find my protractor and move it. Let's move my protractor down to my circle. Right, now I have a protractor. What I need to ensure on the protractor is that my 0 is at my line, my 12 o'clock. So let's try and move this protractor around. Flip it round. So 0 is at 12 o'clock. Right, now my problem is I need 216 degrees and my protractor only takes me up to 180. So what am I going to do? I'm going to make a note and a mark where 180 is. So I'm going to mark this 180, and then I'm going to actually finish my line. So let's go back, let's move our protractor out for a second and complete this line to 180. So that is 180, but I need 216. So I'm going to do the balance. So let's find what the balance is. I take my 216 minus 180, and I end up with 36. So I need another 36 degrees here. So let's get our protractor back in line. We're now going to make that our 0. We need to flip our protractor around. No, it's not turning. Right. And I'm going to count off 36. So let's get a color. And we count 36 and we make a mark where 36 is. Okay, that's definitely not working. We make a mark at 36, and we're going to move our protractor aside and we're going to join the dots. So let's move the protractor, and I'm going to join this line from my center to my 36, and then I can delete this line. Okay, so basically that is my impala. So what we're going to do is we're going to delete this line because we don't need it, because in actual fact we need 218 degrees, 216 degrees. And now we carry on drawing, because now we're going to do our next one, which is 72. So we put our protractor back. Now remember, my protractor needs to now, where's my 0? My 0 is in actual fact, put that back in line and turn it round. My 0 needs to be on my new line. And we then read 72 degrees. And we carry on doing this until we've actually got our, so let's make a mark at 72. We carry on doing this until we've got our pie chart completed. So let's move the protractor aside, draw a line. It's not the most accurate because I don't think my circle's the most accurate. But then after that we need 54. So we put our protractor back. And now my new line is 0. Move my protractor a little bit. I need 54. So let's draw a line at 54. Okay, join that, move my protractor aside, join that line. And finally, what we should be left with is 18 degrees. And then what's important, what have I left out of this calculations? First of all, I've left out my heading. So I need a pie chart of animals, not animals, animals was the last one. A pie chart of nutrients in bread. Okay, so that's important. Now in this particular case, I don't have axes to label, but I do need to label each one of the parts. So let's get rid of our protractor, so we don't need that any longer. And now we can label these. So what have I got? I've got impala. Impala, I'm going back to this thing. I've got carbohydrates. And I can add that it was 60%. Now another thing that's important is when you're doing this, make sense of the answer. Am I expecting something that's more than half? I am, it's 60%, that's more than half. So if I look at my part of my whole, I see that it's bigger, then I think, well, I'm probably on the right track. The next one we had was fat, and add your percentage, which was 20%. Then we had fiber at 15%. And finally, we had protein. Now, if you don't have enough space in your graph, you can actually add a label to it. And let's just add that, and we'll put it on the side. Protein, and it was 5%. Okay, so there's your pie chart. Fairly easy, something you need to practice. Let's move on to the next question. Right, we've got our question with, and Tombi and her 5 friends are planning a 5-day holiday. As none of them own a car, they decide to hire a Toyota Avanza from Awis Car Hire for 5 days. They will have to pay a rental cost plus an additional cost for petrol used. As part of their rental costs, Awis Car Hire offer 200 kilometers free per day. Total rental cost for 5 days is 2,000 Rand plus the number of kilometers over 1,000 kilometers. I think let's just add, let's try to find some white. Let's add these thousands here and ignore them here. 1,000 kilometers times 3 Rand. So there's our formula. And there's an important formula. So I think maybe we should highlight this in a different color so we can see we've got the total cost was 2,000 Rand plus the number of kilometers over 1,000 times 3. And Tombi worked out the total rental cost for 5 days for various distances traveled, and she then drew a graph to illustrate her calculations. So let's look at her graph. First of all, we're looking at the total rental cost. We should have actually included here and distance traveled. What are our axes? We've got our cost in Rand, and we go from 500 to 4,000 in even increments, and the distance traveled in kilometers, and she goes from 0 to 1,600 kilometers. Now the question says, use the graph to write down the total rental cost over the 5 days if Ntombi and her friends travel 975 kilometers. So we want them to go 975 kilometers. Well, what do? We find our 975 on our graph. Now remember, we've got 800, 1,000. 975 is close to 1,000. So I'm going to draw a graph up, and I don't even need to draw a line across because my line across is my graph. So how much is she paying for 975 kilometers? The answer to this is 2,000 Rand. And remember, that's our cost in Rand. So we always have a reference, so it's 2,000 Rand. If she travels 1,300 kilometers, I think that's a little bit harder. Let's get a line. Right, 1,300 is between 1,200 and 1,400. We draw a graph line up, and from that we draw a line across, and we read off our graph, and it's just under 3,000. So I'm going to take a guess as to what that is. It was 2,000, call it 2,900. And this is where there will be a fair amount of leeway for you to decide, but we need to see the calculations. So show these lines on your graph. And in actual fact, you can even say to your examiner, check out my paper where I've drawn the graphs, because it makes it easier for them to see what you've been doing. And let's see what the next part of her question is. Right, we've still got our example. Determine the maximum number of kilometers they could travel in 5 days if they set aside 3,500 Rand to pay for the car hire. So we're doing this one in reverse. We now know how much she has to spend. They've got 3,500 to spend. We're going to draw a line to our graph. And then from our graph, we're going to draw a line down, and we're going to read off that value. So now that value there is a little bit more than 1,400. I'd say less than 1,500 because it looks a little bit closer to 1,400 than 1,600. So we're going to say that it was maybe 1,480. And remember, we've got a value, kilometers. Right, let's look at the next part of the question. I'll read this again. On a particular day, Ntombi and her friend covered a distance of 360 kilometers. The time taken to travel the 360 kilometers at various speeds is shown on the table below. So let's read our table. We've got our speed in kilometers per hour, and then we've got our time in hours. So if she was traveling at 10 kilometers per hour, or should I say they were traveling at 10 kilometers per hour, it would take them 36 hours to travel. If they were traveling at 20 kilometers, 18. And let's just check the highest. If they were traveling at 120 kilometers an hour, it would take them 3 hours. Now we're looking for the value of A and B. We're looking to determine the value of A and B. So what can we see? If I take my 10 times 36, I'm going to end up with 360. If I take my 120 and times by 3, I end up with 360. So what I'm looking at is taking my speed and timesing it by my time, and I'm going to get 360. So the other way around, well, I'll take my 360 to work out A. Let's take our 360 and divide it by 30, and we're going to get A. Let's do that on the calculator with 360 divided by 30, and I see that it is 12. So my answer is 12. And what is my answer? 12 hours. Now, if I'm going to fill that into the table, am I expecting a number between 18 and 30? Between 18 and 8. I'm expecting a number between the two, because otherwise they would have put it somewhere else in the table. So if I don't get a number that is between 8 and 18, I think to myself, bells are going off, and I think, no, I've made a mistake. So if I get an answer between, I think, well, I'm on the right track, so must be right. Let's do B. For B, we can do the same calculation. Let's change color. We've got 360 divided by 6 is going to equal to B. And what does our B equal? Let's do the calculator. 360 divided by 6, and we get 60. So B is 60, and this is now kilometers per hour. So don't forget your units. Am I expecting this? I'm expecting a number between 45 and 90, so that's perfect. 60 seems like a good answer. Before I move on to the next question, I just want to go back to this graph for a second, and I want us to look at, because they haven't covered it in the question, why have I got this straight line of 2,000 Rand up to this value? And the answer to that, and it's important that we understand that, is that the car rental charged 2,000 Rand, plus they charged a number of kilometers over 1,000 Rand at 3 Rand. So up until 1,000 kilometers, they were charging a set rate of 2,000 Rand. And thereafter, this increased at a rate of 3 Rand per kilometer. And that is why we've got two parts of this graph. So I just wanted to point that out to you before we carried on with the next question. So okay, let's move on to the next question. So our next question is now got, question 4 says, given a graph showing the monthly number of immigrants, that's people moving to a country, to South Africa from January 2000 to June 2003. So what are we looking at here? Let's first interpret our graph. So our title of our graph says the total number of immigrants to South Africa per month, January 2000 to June 2003. And you can see on our axes we've got the number of months, and we've got January 2000 to May 2003. Well, in actual fact, to June 2003. Okay? And then we've got the number of immigrants. So we've got numbers from 0 to 550. And these are all connected, and we can do a lot of interpretation from this graph. We can see how many people moved into the country on in a particular month. What I want to point out to you, and this is a graph that's been taken probably off the internet somewhere. What I want to point out to you is this graph should actually have been a broken line graph, because they are not continuous. I cannot read a value in between. I can read in between the numbers on this axis. I can look at the numbers on this axis, but I cannot do a reading between June and July. There is no value between June and July. The only thing that does work in this case is that we do have between January and March, we do have February, but that's a dot. In between these dots, it should have been a broken line, because we cannot have January and a half, or anywhere between January and February. We have either January or February. So have a look out for this, because it's something that I notice that comes up quite often as a solid line graph, which should possibly be a broken line graph. Okay, let's go ahead now and let's answer some questions. Now my questions are at the bottom here, so I'm going to go down there. Right. The first question says, what was the number of immigrants to South Africa in January 2000? So what we need to do is go back to our graph and find January 2000. I'm going to use my straight line. January 2000, well, that's quite easy, because January 2000 is the start of my graph. I go up and I can see that it is 200. So all I need to do is go back and answer the question. And let's put, right, I've got 200. And what is this? 200 what? 200 people, because they immigrated to South Africa. What was the number of immigrants to South Africa in January 2001? Well, let's look at that question now. So now we're going to January 01, and we're going to again draw a line up from January 01, draw a line up to our graph and across, and now we can see that it is slightly more than 200, but less than 250, and quite a bit less than 250. So I'm going to go with probably 210. So in this case, I'm going to say that it is 210 people. Now, I don't think in this particular case I've done it, but what we then like to do is kind of extend the question and now take you to percentage and maybe work out the percentage increase of the number of people that immigrated. Or we could ask you to manipulate this in some way. So you know what? Let's quickly do a revision of percentage increase. So let's work out our percentage increase. Well, we need our percentage increase is our new number. We're going to take our old number. So we're going to look at our percentage change, and we're going to divide that by what our original was and times by 100. Just on the side, while we're doing this, let's work out our percentage. So it's 210 minus 200. That gives me my change. So I'm looking at 10 different. There were 10 more. I'm going to divide it by my original, and then take that answer and times by 100 to get a percentage, and see that I've got a 5% increase. 5% increase from one year to the other. Now, when you're only dealing with 10 people, that doesn't seem like a lot. But in actual fact, if I say to you that it increased by 5%, that seems like a whole lot more than just the 10 people. Okay, let's move on to our next question. Our next question is dealing with this graph here. Now we've given the graph showing the immigrants who come to South Africa are from as well as the total number of immigrants from 2000 to 2003. So our first graph that we dealt with in the last question was just how many people have immigrated. Now we're telling us where are they from and how many people immigrated. Where do the immigrants to South Africa come from between 2000 and 2003? And we've got our total number of 12,733 people. And from this we can see that it's broken up into our pie charts, parts of our whole. So 36% of those people came from Europe, 5% came from Americas, 30% from Asia, 2% from Australia and New Zealand, and finally 27% came from Africa. And in that case we're dealing with the rest of Africa. Let's see what our questions are. What was the percentage change in the number of immigrants between January and June? You see, I know these questions. We've just done that calculation. So we can do the calculation again. We've done it. So our percentage change was 5%. What is our next question? Calculate the number of immigrants who came to South Africa from 2000 to 2003 from Europe and Asia. We're looking at Europe and Asia, and we want the number. So now we're going to be dealing with the second part. We want Europe and Asia. So first of all, we need to work out, we can do this two ways. We can either work out the number from Europe and the number from Asia and then add them. Alternatively, we can work out the percentage of Europe and Asia. So let's do it that way. Europe was 36% and Asia was 30%. So in total, we have 66% of the people came from Europe and Asia. But 66% of what? We need our number, 12,733. So we're going to take our number of 12,733 and times that by 66%. And that's going to give me the number of people. Let's do that on the calculator. So 12,733 times by 66%. And I always want you to double check what you're entering on your calculator is in actual fact what you've written in your books. Because don't just get an answer on the calculator and say, well, I know it's true because the calculator said so. Just double check as you're typing. Let's get an answer to that. And we see that it's 8403.78. I'm going to write that number down. It was 8403.78. Now my question said calculate the number of immigrants. I cannot have 0.78 of a number of immigrants because I can't just have 3/4 of an immigrant coming. We've either got one or none, but we can't have the fraction. So what we need to do here is we really need to round it off to a whole number. So I'm going to make it 8404. I'm rounding up immigrants or people. I want to know the number of people, so we got people. So 8,404 people came from Europe and Asia. Right, so now that our questions are all finished, I think it's time to quickly do a recap of the whole session and what we've actually done today, and to remind you all to practice and go out and find graphs out there. So we were dealing with graphs and more graphs and more graphs. And remember, there were 4 different types of graphs. We had the line graph, which shows us comparison of one variable towards another. We had the bar graph, which compares categories of similar nature but that are different. Remember, we can put them into any particular order, and we have columns. And remember, you can see through the bars, that's why it's called a bar graph. Then we had the histogram, which was also columns, but now they were next to each other, kind of like a skyline of Joburg or a city, and they're right next to each other because they continue. So we're still comparing values, but we're comparing values of something that continues. And lastly, we had a pie chart which shows us parts of the whole. What was important about the graphs? Remember, you need a heading. Always need a heading, and your heading needs to be meaningful. We then had our axes, which needed to have a label with a unit as well. And we needed to work at our scale very, very carefully. Because remember, each block represents the same number of units, and you need to ensure that you go from the bottom, which is normally 0, to the maximum, and then split up the number of blocks into the units that you have. And we needed to label. And then when interpreting the graphs, remember to just look at the same things, look at the heading, look at the labels of the axes, and to try be accurate when it comes to your graphs. There are times that you can guess, but they are educated guesses. But if it's exactly on a line, it needs to be accurate. And when you're drawing your graphs, accurate. And guys, use rulers. Make it pretty if you want, but always use a ruler. And if you are going to color in something like a bar graph, ensure that you color within the lines, because there's really nothing more frustrating than seeing a graph that is actually correct, but is untidy. So just think about it. Put your examiners into a good mood and your teachers into a good mood when they look at your work and they think, oh, this is pretty. I really want to mark it. Most importantly, guys, practice, practice, practice. So I hope you've enjoyed today's session, and I hope that you understand all about graphs. I hope that you can tackle any graph that you see, and you'll be able to answer any questions about this. And remember, it comes up in so many different sections. So on that note, with practice, 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 I'm going to say goodbye, and I'll see you again shortly. Bye. Thank you.